What if I told you that you could predict a city's worst traffic jams using basically just a map and some really clever math? Well, that's exactly what we're digging into today. A groundbreaking new method that's completely changing how we look at one of the most tangled urban problems out there. I mean, we've all been there, right? Stuck in traffic, going nowhere fast. But have you ever wondered how city planners are supposed to predict where and when those jams are going to happen? It's a massive, critical question for any city that's trying to grow. And the wild part is, for a huge number of cities, especially in the developing world, the answer is they can't. They just don't. The old school methods are way too hungry for data and just cost a fortune to implement. Okay, so here's how we're going to break this down. First, we'll talk about just how big this problem is. Then, we'll get into why the old models just don't cut it anymore. After that, we'll explore this brilliant new idea of seeing cities as networks, break down the actual formula, and see how it held up when they tested it all over the globe. And stick around for the end because the result is a real game changer. So first up, let's just be clear why this matters so much. Because, traffic that's out of control isn't just annoying, it's a huge, expensive drain on our cities and, honestly, on our lives. You see, when planners can't get a grip on traffic, the fallout is serious. We're talking about mind-numbing congestion that wastes millions of hours, a higher risk of accidents, some truly awful air pollution, and it literally slows down the economy. So yeah, getting this right is a pretty big deal. Okay, so if it's so critical, why are the tools we have now falling so short? Well, it pretty much all comes down to what you could call a data dilemma. And this slide, wow, it really lays out the whole problem. On the one hand, you have the traditional traffic models. They need a mountain of data, tons of traffic counts, expensive surveys, super detailed maps, and a whole team of experts. But on the other hand, you have the reality for so many cities. They just don't have the money, the data, or the people to make that happen. There's a huge gap. So this is where things get really, really interesting. This is the breakthrough. Instead of trying to chase more and more data, this new approach just completely flips the problem on its head. And this quote just nails it. The secret isn't buried in some massive new data set. It's hiding in plain sight, in the very structure of the road network itself. It's about seeing the city not just as a bunch of streets, but as a deeply interconnected network. Now, to get this, you really only need to understand two key ideas. The first one is called closeness centrality. It sounds complicated, but it's not. All it means is, how easy is it to get from this road to everywhere else? Think of a busy downtown shopping district. Those streets are great destinations, so they have high closeness centrality. And then we have the second concept, betweenness centrality. This one's about how often a road is part of the quickest route between two other places. It's a measure of how good a road is for just passing through. Your big highways, your main arteries, those are the roads with high betweenness. So if you put it all together, it's pretty simple, right? The traffic on any road is basically just a mix of these two things. It's some people driving to that area, those are the destination trips, and it's other people driving through it to get somewhere else, the pass-by trips. That's it. All right, so how do we turn these cool ideas into something that actually works? How do you make a real formula out of it? This is where the theory gets real. The logic is super straightforward. You start with the traffic on a road. You know it's a mix of its closeness and its betweenness. But the researchers who came up with this realized they needed one more special ingredient to make it truly accurate. And that ingredient is something they call path distance. And this is the secret sauce. See, instead of just measuring how long a road is in miles or kilometers, path distance is smarter. It knows that a mile on a 6-lane highway is totally different from a mile on a clogged-up city street. It factors in things like road type and average speed, and that makes the model so much more powerful. So, look, a theory is great and all, but the real question is, does it actually work in the chaos of a real city? Well, the researchers decided to put it to the test, and they picked some of the most challenging cities on the planet. They started in Colombo, Sri Lanka. You can see its kind of radial, star-shaped road pattern right here. The model crunched the numbers on the network's closeness and betweenness, and this map shows what it predicted. The red lines? Those are the traffic hotspots it identified. And believe me, this was not a one-hit wonder. They tried it on the perfect grid of Phnom Penh, and then they threw it at the massive, sprawling, chaotic network of Karachi. And every single time, in totally different kinds of cities, the model's predictions were spot on. And hey, don't just take my word for it. The numbers are pretty staggering. This table shows the model's accuracy score. It's called an R-squared value. Just think of it like a grade on a test. 1.0 would be a perfect score, and 0 would be useless. As you can see, every single city scored above zero point 0.9. That's like getting an A+ on every exam. It's unbelievably accurate. And let me just put that number into perspective for you. An accuracy score over 0.90 means that this super simple, low-data model works just as well as the most complicated, expensive, data-hungry models that are used in the wealthiest cities in the world. It meets the absolute highest international standards. I mean, that's already incredible, right? But honestly, we haven't even gotten to the most mind-blowing part yet. To get that world-class accuracy, how much real traffic data did the model actually need? You're not going to believe it. It's this number. 40. That is not a typo. The model gets these top-tier results using traffic counts from just 40 little observation points in the entire city. That is a tiny, tiny fraction of what the old models need, which means this incredible tool is now within reach for practically any city, anywhere on Earth. And that really leaves us with a huge and fascinating question, doesn't it? What if the answers to our most complex problems aren't about spending millions to collect more data, but about finding a smarter, more elegant way to understand the simple data that's been right in front of our faces the whole time? In this case, it was all just waiting on the map.